I'm gonna do two-way tables and topic 6 and topic 7 in this one. So to complete your two-way table, we need to have the totals add up. So we can do 49 minus 21. So 49 minus 21 is 28. We're adding the columns, so 126 plus 64 is 190. Here, this column has to add up, so you can do 28 plus 26 subtracted from 157. So 28 plus 126. Is 154. So 157 minus 154 is 3. So this to be 3. 3 plus 8 is 11. 21 plus 64 plus 8 is 93. 40 plus 190 plus 11 is 250. And to check my answer, I can do 157 plus 93 to also get 250. So the whole survey was about 250 girls and boys. So what percent of surveyed are girls? So what is the probability that they're girls as a percent? So there are 93 girls out of 250. So in the calculator, we're doing, I want to do the full screen. 93 divided by 250 times 100. 37.2%. Percent probability. What percent of the surveyed did not have brown eyes? I'm going to say brown with the apostrophe, so not brown. Or sometimes it's written with this little squiggly, so not brown. It's honestly easier to find the probability that they had brown and then subtract that from 1. So, but not brown, out of all the students, 250, not brown was blue and green, so 49 plus 11. 49 plus 11 is 60 out of 250, and times that by 100. 60 divided by 250 times 100. 24%. Again, another way you could do it is just 1 minus the brown, 190 over 250. Would also get you 60 over 250. So, however you want to do it, it doesn't matter. It'll still give you 24%. What percent of the surveyed are boys with brown eyes? So probability that it's a boy and they have brown eyes. Oh, that's blue. Blue eyes. So out of the 250, boy with blue eyes is 28. 28 out of 250 times 100, 11.2. So to make it into a percent, all I'm doing is timesing your fraction by 100. What percent of the surveyed have brown or green eyes?
Delasha Jones, your ride is out front. Delasha Jones, your ride is out front.
Brown or green, so we're combining them. So we're going to need to combine these two. 190 plus 11 out of the total of 250, so that'd be 201 out of 250. Times that by 100. 80.4%. Okay. Next 2A table, we need the totals. So this would be 16, this would be 15 plus 8, 23, 12 plus 9, 21, 6 plus 15, add the columns, 10 plus 8 plus 9 is 27, 16 plus 23 plus 21 is 60. So our total is 60. You could also add these two, 33 plus 27, just to check your answer, that your total is 60. All right, so what is the probability that the marble is green? Out of 60, out of the total, green is 21. And it doesn't say how to write it, so I'm just gonna write it as a simplified fraction. So that would be 7 over 20. Probability a solid or blue, so out of the total, solid is here, these 27, and then blue includes this 15. So it's these, but we just don't want to double count that 8. So let me circle it a different way. So this one's blue, this one's blue. So blue would be true or solid would be true. So these also would count, those 4 added together. So 15 plus 10 plus 8 plus 9 is 42 out of 60. And in the calculator, 7 out of 10 when you simplify it. Now, C and D are given, so conditional. So remember, always start at the bottom. Given, they are in green. Given is a green marble. So given is a green marble. So out of these 21, we're just looking at those 21 marbles. How many marbles are striped? 12. So 12 out of 21, which is 4 out of 7.
Abby Miles, your ride is out in the front of the school. Abby Miles, your ride is out in the front.
And then solid, there's 27 and not blue. So out of these 27, just look at those 27, which ones are not blue are these 19. 19 out of 27. And that doesn't simplify, so that'd just be your answer. All right, permutations and combinations. I know this is what we're worried about. So with permutations, the order matters. So if you're making a list, a sequence, or a position, you use permutation. Combination order does not matter, and so when you're making a group of people, it doesn't matter who you choose first; they're still in the group. So the number of ways 18 runners can win first, second, and third, those are positions. So that has to be a permutation. They care if you give them first when they came in third. So out of the 18 runners, we're picking 3 of them. And then in the calculator, I'll put in 2 of these. I'm not gonna put all of them. But it's under math. You wanna put in the number first. So you wanna do 18 first and then hit math. Scroll over to probability, PRB, and permutations is number 2. And the big number always goes first, 18 and we're picking 3. So out of 18 runners, we need to pick 3 of them for first, second, and third place. There are 4,896 ways to do that. 4,896 ways to do that. Okay. A number of pizzas, you're choosing the number of ways to choose 3 slices of pizza from a pizza cut into 16 pieces. So you're putting 3 slices of pizza on your plate. It doesn't matter the order you put them, they're all going to end up on your plate. So out of the 16, the big number always goes first. How many you're choosing? We're choosing 3. Doesn't matter the order we put them on our plate, it will still work. So again, put the big number first, and then combination 3. Math, scroll over to probability, combinations, and choose 3. 560. Okay. The number of ways to arrange the letters in the words journey, well, that would matter because if I put J-O or O-J, that order matters. But there are 1, 2, 3, 4, 5, 6, 7 letters in journey, and we need to pick all 7 of them because we're going to rearrange them. So this will be 7 times 6 times 5 times 4 times 3 times 2 times 1, or 5,040. The number of ways to create a 4-person committee or group of 25 people. That order doesn't matter. As long as they're in the committee, it doesn't matter if I chose them first or last, they're still making the same group. And we put that in the calculator, get 12,650. The number of ways to form a 12-person jury from a pool of 40. That's a group, a committee. Those people in the jury, it doesn't matter if they were chose first or last, they are going to make the decision. So as a combination, out of the 12, we need a group of 12. Out of the 40, we need a group of 12. This is that huge number, 5,586,853,480. 5,586,853,480. The number of a 6-digit passcode possible using the digits 1 through 8 if the digits cannot repeat. So out of 8 numbers, they can't repeat. Passcodes, the order matters. And we need 6 digits. 6 digits not repeating. So 8, pick 6, 20,160. Okay. I don't think that's what we're worried about. I think we're worried about these last 4. So, a class containing 12 girls and 16 boys. If a group of 5 people is formed from the class, what is the probability that they are all boys? So first, how many different ways can you choose 5 people, one group, out of this whole class? That's the denominator. We're choosing them to form a group. Order doesn't matter. If I choose you first or last, you're the same. But we're choosing out of 12 plus 16 people. 28. So the class is 28, and we're making groups of 5. This is all the ways you can choose 5 people from 28, where order doesn't matter. Now, on top, we're finding the probability that they are all boys. Well, there are 16 boys. So there are 16 boys we're choosing from, and we're trying to figure out how many ways can we choose 5 different boys from that. And then we'll put that in the calculator. So I always do my fraction first. Alpha y equals enter. 16, math, go over to choose, and then we're choosing 5, and then on the bottom, that's out of 28. And again, we're choosing 5, combination of 5, 2 out of 45. If you want to put them in the calculator separate, this is the work I need to see. Tells me you chose it was a combination, not a permutation. Tells me you know how many you're looking out for. But just in case you put them in the calculator separate, then I do want you to put them, the fraction in to reduce it to over 45. To enter a video call with their teacher, each student must enter a unique passcode that begins with 3 capital letters that do not repeat. What is the probability that the passcode begins with A, B, and C? So, that in the alphabet, this is a passcode, order matters, permutation. There are 26 letters in the alphabet, and we're choosing 3 of them. That's the total amount of passwords that can be made from the alphabet. Now, what is the probability that the student's passcode begins with A, B, C? That's it. That's one option, A, B, C. You can be complicated and say, 1, pick 1. I want an A. A, 1, pick 1. A, pick A, basically. That's one chance. So A has to be first, B has to be second, and C has to be third. So this is just 1. There's only one way to perform that, A, B, C. And then put that in the calculator, you get 15,600. There are 30 calculators. There are 30 calculators numbered 1 through 30 in a case. If 4 calculators are broken, what is the probability that the number on the broken calculators are at least 16? So on the bottom, out of the 30 calculators, we need to know how we can choose 4 that are broken. Combination, because it doesn't matter if I pick up 1, 2, 3, and 4, it doesn't matter the order, they're broken. So 30 choose 4 calculators is our combination, order doesn't matter. 30 combination of 4. On top, we want to know what is the probability that the number on the broken calculator is at least 16. At least 16 is 16 or more. So 16 or more, that's how many total we're choosing from. So how many would make it successful? So out of this many, 16 all the way to 30 is, and we're still choosing 4. That's 15. I'll write them all down real fast. So this is where the 15 number comes from. So how many 15 out of these 15 calculators, if we only are looking at the 15 calculators that are at least 16 or more, labeled 16 or higher, how many ways can we choose those 4 to be broken? 15, choose 4. Put in the calculator, 1, 3, 6, 5. Okay, if you skip this step, just put it all in the calculator. But if you don't, I want to make sure you can get those numbers. This is where your partial credit on your test is coming from, though. So 13 over 261. All right. Laura's filling 3 empty photo frames on her mantle by randomly using individual pictures of her 8 grandchildren. If Ben is her grandson, what is the probability that his picture is in the middle frame? So she has 8 grandchildren, and this is the order of pictures. If you talk to any decorator, that order matters. So order matters, permutation, and there's 3 frames. So out of the 8 kids, there are 336 ways to organize 3 of their pictures. Now, if Ben is in the middle, we know that one. So to show you how I showed you in class, Ben is in the middle. There's no option. That's 1. But here we have, so this was 1. This is Ben. So there was 8. Now we got rid of Ben. Now there's 7 to choose from. So I could do 7, choose 1 here, and 7 choose, no, now we'd be down to 6, choose 1 here. But that's, not choose, I apologize, pick. 7, pick 1, 7, 6, oh my goodness, because it's going down 1, 6, pick 1. But that is a lot harder than just saying 1, because of Ben, and then the other 7, we have to pick 2 of them from. Either way, it would work. Doesn't matter if you multiply by 1 or not. These are the 2 out of the 7 grandkids, because Ben's already chosen. There's 7 kids left. We need to choose the other 2. Or we know 1. We need to pick. This is going to mess up because I didn't write it. We have 7. We need to pick 1 to go on the left. And now we're down to 6, and we need to pick it to go on the right of Ben's picture, which is also 42. This just looks way more complicated than, you already know where 1 is, we just need to choose the other 2. But it is 42. However you want to get there is 1 out of 8. Okay, so that's topic 5 and topic 6.